Okay, so let's continue solving these trig equations. So now we have to find all the solutions. So we want to find the cosine of x is equal to negative 0.4. So in this case, notice that negative 0.4 is not on the unit circle. So if we look at the unit circle, there is no point where you have a negative 0.4, which means that if something is not in the unit circle, then we have to use our calculator. Okay, so the first thing that we want to be able to do is, well, in order to get rid of the cosine, you're going to have to write inverse sine to both sides, or the arc sine. So I'm going to take cosine inverse to both sides. I'm going to take cosine inverse to both sides, cosine to the negative 1. So this is going to go away. I'm left with x is equal to cosine inverse of negative 0.4. Okay, so that's one solution. So this is basically what we call the exact solution. If you want the approximation, all you got to do is just basically put this in your calculator. So let's go ahead and put cosine inverse. Let's change this to radians. So we're going to do cosine inverse of negative 0.4. And what you're going to get is about 1.98. About that point. Okay. Now, one of the things to kind of also think about is that if you were to do that, this negative 0.4, you should know that there's actually another solution as well. So this is the first solution. Where is the next solution? Okay, because so far, whenever we take the cosine, well, if you think of the cosine being negative 0.4, and we look at all the possibilities where that can occur, okay, well, here we have all students take calculus. All right, so we want to figure out where exactly you're going to get negative 0.4. Well, the first one, this 1.8, is not even close to pi, right? So here's pi, and here's pi over 2, right? So basically, negative 0.4 is probably around here, okay? This is the angle. So this is 1.98 radians. And if you want to put them in degrees, you can, and you'll see that it's 113 degrees. So let me write it right here. This guy is basically 113 degrees. So if it's easier for you to write it in degrees, just write it in degrees or figure it out. So we need to figure out where else am I going to get the cosine being negative 0.4. Well, notice that here cosine is positive. We already got this one. This guy cosine is negative because this one's positive. So that means that the other one is going to be right here. Here's my other solution. Okay. What angle is this? Okay. So one of the things that you can do is, here's where you have to tap into your geometry. So this whole thing is 113 degrees, or 1.98 radians. Okay. So what we need to figure out is, how much do I have to go so I can get here? All right, well, one of the things that you can do is you can try to figure out, well, let's try to figure out what this angle is, okay? Because this angle and this angle should be exactly the same, okay? Well, this whole thing is pi. This is basically a supplementary angle. If you look at this guy right here, this is a supplementary angle. If this is 1.98, then I can, how can I get the other one? Well, this is going to be pi minus that number. So pi minus 1.98 is going to give me 1.16. So this guy is 1.16. All right, so if that guy is 1.16, that means that this guy right here is also 1.16. So how do I get this angle right here? Well, I know that all of this is 180, okay? From here to here, all of this is 180. So all I got to do is add this extra 1.16. So take 180, or pi, and add it to 1.16. And that's going to give me 4.3. Okay, so basically my other solution, x2, is going to be 4.3. Okay, so yes, it is you have to use a little bit of geometry, because, or else you won't be able to do problems like this. So when they're not in the unit circle, you do have to do a little bit of geometry. You have to use these reference angles to be able to do it. Okay, now this is not the solutions because we want all of them. So basically my full solution will be x is equal to 1.98 plus 2 pi k, and then 4.3 plus 2 pi k. And then here, k is an integer. Okay, so that is my solution. Okay, so a little bit involved. Okay, so now let's do the next problem. I have 2 sine x is equal to 0. Okay, so let's solve for sine first. So let's divide by the 2. So you're going to get sine of x is equal to 0. So now we need to figure out where exactly sine of x equals 0. Okay, so here's a unit circle. 0 is on the unit circle, so we're looking for all the y values. So here is 0, and here is 0. Okay, so all we just have is 0 and pi. So usually it would be x is equal to 0 and pi. So if you wanted all solutions, what you would write is x is equal to 0 plus 2 pi k, and then pi plus 2 pi k. And here k is an integer. Now this can be a little bit repetitive. I don't think that's how you spell it. Repetitive. Okay, so this is a little bit repetitive because basically if you just look at the angles, you're just adding a factor of pi. I just add pi and I get to the next one. I add pi and I get to the next one. So another solution could easily be x is equal to 0 plus pi k. Okay, so this is another solution that you can actually have. This is actually a much nicer solution because then you just have one equation that you can kind of just try to program if you were programming the solutions. And this actually is a little bit better to write than just having two of them and just having multiple angles. Okay, so sometimes it's easier for an exam if you do, because you're kind of getting used to them right now, it'll be okay if you do it the repetitive way. But if not, it'll be nicer to just write it as 0 plus pi k. Okay. All right, so now we have some trig equations for tangent and cotangent. So we can also find it for these two guys. So now we have to be very careful with these guys because if you remember that when you were graphing these guys, the period for sine, cosine, secant, and cosecant was 2 pi. Now in this case, for tangent and cotangent, the period is pi. So that means things tend to repeat every pi units. So when we look for all of the solutions, instead of doing a plus, we will do a plus pi k instead of a plus 2 pi k. Okay, so that's the only thing that's a little bit different. All right, so here we want to solve the equation tangent of phi is equal to square root of 3 plus square root of 3 for all solutions. Okay, so we want to be able to figure out where exactly this guy is at. So one of the things that you can do, you can always print out a unit circle, and then let me get rid of all this stuff. We know that tangent is basically sine x over cosine x. That's what we know. That's going to be tangent of x. So we can actually figure out the tangent, kind of make a new point and figure out what tangent in this case is going to be. That way it's easier to figure it out in the unit circle. So here, because it's a sine over cosine, in this case you're going to get 1 over square root of 3. Okay, if I divide the 1/2 divided by square root of 3 over 2. Another way that you can write it is by rationalizing it, so it will be square root of 3 over 3. Okay, this guy will just be 1. This guy will just be square root of 3. Okay, and then you can kind of just do the same thing over and over again, just so that you can kind of like get a little glimpse of what this kind of looks like. Same thing over here, square root of 3 over 3, 1 square root of 3, and then this guy is going to be the swapped version, so square root of 3, negative 1, and then negative square root of 3 over 3. And you can also do the quadrantal angle, so here it will be 0, here will be undefined, here it will be 0, and here it will be undefined. So if you ever wanted to make it a third coordinate, which you wouldn't call it a coordinate, but a third point, for tangent, then you can always just do that one if you want on a unit circle. Okay, very, very easily. So now all we want to figure out, let's go back to the equation. We want to find where is phi, so tangent of phi is equal to square root of 3. Okay, so let's look for them. Okay, we want all the solutions. So what we can do is you can just take square root of 3, so we're square root of 3 right here. Okay, and what angle does that correspond with? That corresponds with pi over 3. Okay, so the first guy, so notice that here, and then the other one is going to be this guy for 4 pi over 3. But notice that these guys are 180 degrees away. So if I add 180 degrees, I get to the next one. So typically, I don't really need all of them. I can do both of them if I wanted to. Pi over 3 plus 4 pi over, plus pi over 3 and 4 pi over 3. So if I just wanted both of the solutions, it will be pi over 3 and 4 pi over 3. But in this case, since I want all of them, you can write this. You can write phi is equal to pi over 3 plus pi k and 4 pi over 3 plus pi k. Whoops. Oh god. Why is it not erased? Oh, there you go. Plus pi k. And here k is an integer. So you can write that if you want to. This was a suitable solution. But another way that you can write it is just write pi over 3 plus pi k. Because this pi is just going to be added continuously to this pi over 3. So I start at pi over 3 and I add pi units and I'm going to be at the next one. I add pi units, I'm going to be at this point again. I add pi units and I get this one. Then pi units continues on. Okay, so basically I didn't really have to do it over and over and over again. You just have to be strategic about where the points are at. So again, if you wrote this, that's okay. Typically, this was more of an acceptable answer. Okay, so now let's do a couple more complicated problems before we get to the algebraic ones. So, so let's start off with this one. So I think the easiest way to do it is just starting off with the interval from 0 to 2 pi, because the other guys are just going to be added to pi k. So here we want to find the tangent of theta minus pi over 2 is equal to 1. So the first thing that you kind of want to think about is look at this theta minus pi over 2, okay? Now, this guy, we can't quite solve for it. You can't add the pi over 2. We need to get rid of this tangent. So the way that we do it is by taking tangent inverse. So this is going to go away. I'm left with theta minus pi over 2 is equal to the tangent inverse of 1. So we got to think about what are all the angles where I get 1. So let's go to the unit circle. In the unit circle, all of the angles that give me 1, let me erase all of this stuff. Oh god, I erased too much. 1 and square root of 3. So we want to look at, what was it? Where is tangent inverse equal to 1? So here is one of them, that's pi over 4. And then here's another one, at 5 pi over 4. So at pi over 4, okay, so at pi over 4 and at 5 pi over 4 is where I get these two things, okay? And now what I want to do, I want to go ahead and use this pi over 2, okay? So, because I still need to figure out what this theta value is going to be. So what I'm going to do is I'm going to add this pi over 2 to both of these guys. So I'm going to get theta is equal to, so here's where you're going to use your handy dandy calculator. So it's going to be pi over 4 plus pi over 2. Okay, and you're going to get 3 pi over 4. And then here you're going to have 5 pi over 4 plus pi over 2. Okay, you're going to get 7 pi over 4. Typically with these problems, you have to be very, very careful because sometimes you can be missing a solution. So alternatively, what you can kind of do is first solve them for all of the solutions. So and then just get all the values that are between 0 and 2 pi. So you can always just write it like this. Solve for all the solutions, so everything will be the same. Theta minus pi over 2 equals pi over 4 plus pi k. And then because we know that if I add pi k, I'm going to get 5 pi over 4. I'm just going to leave it as is. Okay. And then just add the pi over 2. Okay, so I'm going to add this, and what I get is theta is equal to pi over 4. Oops, that's wrong. 3 pi over 4 plus pi k. All right, so we have that solution. Now, since we want all of the solutions that are lying between the interval from 0 to 2 pi, this is where this k now plays a role. So if I say k equals 0, then I'm just going to get 3 pi over 4. 3 pi over 4 clearly is between 0 to 2 pi. So that one's going to be a solution. So now what we want to do is let's plug in k equals 1. So let's say I add 1 k unit. So if I say 3 pi over 4, I plug in k equals 1, I'm going to add a pi. I'm going to get 3 pi over 4 plus, let me change this now. This is going to be 4 pi over 4. This is going to give me 7 pi over 4. 7 pi over 4 lies in the interval, so that's the solution. Okay, now another point that you can put is k equals 2. So I'm going to have 3 pi over 4 plus, now I'm going to plug in 2 in here. So that's going to give me 2 pi. So you're going to get 3 pi over 4 plus, this is going to be a 4 on the bottom. On the top is going to be an 8 pi. Okay, 8 plus that's going to give me 11 pi over 4. Clearly, 11 pi over 4 exceeds 2 pi. So this is not a solution. Okay, so that means this is the highest solution between 0 to 2 pi. Now, what is the lowest solution? Is 3 pi over 4 the slowest? Well, let's see. We have to go one lower. So 0 already gives me 3 pi over 4. So let me plug in k equals -1, because -1 is also an integer. So when I do that, I'm going to add negative pi. So it's basically 3 pi over 4 minus 4 pi over 4, which gives me negative pi over 4. That is below 0, so that is not a solution. So the only time that you really have to do this is when you have something inside of the trigonometric function. So see how we had a theta minus pi over 2? You need to check all of these different guys. Here we were lucky. We were able to get both of these points within our interval, okay? But there are some times where you might be missing a couple points where it's better to solve for the general case first and then plug in values for k to make sure that it's between 0 to 2 pi. So that's actually what I would really highly recommend. Only do this if you have something in the inside, which I think there might be a problem that we have to do, which we will do in the next two. So let's just finish up this video by just doing this problem. So I'm going to go ahead and distribute these two. So I'm going to have 2 tangent of x plus 6 is equal to 5 plus tangent of x. Okay, notice that I need to combine the like terms in this case. So let me subtract the tangent over, subtract tan of x. So here I'm going to have just 1 tangent of x plus 6 is equal to 5. And then I subtract by 6. So I'm going to get tangent of x is equal to -1. -1 is in the unit circle. So, and because I only want the values between 0 and 2 pi, then in that case, I don't need to solve for the general because there's no x in the inside. So now what we want to do is just look at all the values that are in -1. So I'm going to go back to my unit circle. Here is -1. Okay, and that corresponds with 3 pi over 4. This should be a -1. This is a -1, so this is 7 pi over 4. So 3 pi over 4 and 7 pi over 4 are basically my answers. 3 pi over 4 and 7 pi over 4. These are going to be my solutions because I only want from the interval from 0 to 2 pi. So I don't need to add plus 2 pi k. So in the next video, we'll do the rest of the problems.